Right, so we have a problem here on dynamics about tension. So, as illustrated, two masses are connected via a string of constant length across a pulley and can move without friction under the influence of Earth's gravity. So, the two angles are fixed. So, A is express the string tension as a function of the masses and the angles, and B is determine the condition for which the masses are at rest or in uniform motion. Right, so first is we draw the diagram. So pulley, it's M2 and 1 M2. So first is we're gonna split the forces on each of the blocks. So F parallel, F normal, that is mg, that's F normal, and that's F parallel. Same as on the other side, this is F parallel, this mg, oh pardon that, and F normal. So the tensions will be here and here. Now, so according to the laws of forces, net force equal to ma. Now, so ma equals mg sine alpha, this alpha, and that is beta. Now, beta minus the tension force, it's m1, so divide all that by m1 to get the acceleration. So a now therefore is equal to mg sine alpha minus t over m1. So next is the forces for m2, is the same. So ma equals mg sine beta minus t. Right, so now we got the forces for m2. We see that we've got the a for the acceleration for m1, so we just sub it there. So that would be m2 all over m1 by mg sine alpha minus t equals t minus mg sine beta. Then just multiply this by m2 and this by m1. So we have m2 m1g sine alpha minus m2t equals m1t minus m1 mg sine m2g sine beta. Now we can get tension by itself. So t equals, so wait, let me just put that up. Alright, so in the end we will get both the masses plus m1 as a denominator, and that's m1 m2g. So we can see that there's both the two sine functions here, so multiply that by sine alpha plus sine beta, and tension now is expressed as the function of its mass and its angles respectively. Alright, so the next is
Danny and Grammar.
alright, wait. So next is determine a condition for which the masses are at rest or in uniform motion. So from the problem we can see that it is at rest, meaning the velocity and acceleration are both zero. So, and we also want this one to be equal to that one, so they would be both at rest now. Right, so the force on M1 should be equal to the force on M2. Now we can get that by M1 sine alpha equals M2 sine beta. Oh no, wait, there should be a G here and G. So that's the force on both sides. So you can see that G is common, so G can get M1 sine alpha equals M2 sine beta. We can rearrange that and we get M1 M2 equals sine, so that is sine beta over sine alpha, and that's it.